Hey everyone, so in this video we're going to find the relative extrema of this multivariable function. So step one is to find the critical points. To do that, you start by taking the partial derivatives with respect to x and y, and you set them both equal to 0. So solution. The partial derivative of h with respect to x. So the derivative of 62x is 62. And then you're treating all the y's as constants, so those derivatives will be 0. So this derivative is 0, this derivative is 2x, so minus 2x, and then this derivative here is 0. And we set this equal to 0. Then we do the same thing with respect to y. So h sub y, so this derivative is 0, this derivative here is 62, this derivative is 0, and here you get minus 2y. We set that equal to 0. Okay? So now we solve both of these equations at the same time, simultaneously. So here we add 2x, we get this. Likewise here we add 2y, so we get this. I just wrote it backwards. Added 2x to this side, so I wrote 2x equals 62. Same thing here. Then you solve for x and y. Looks like in both cases you get x equals 31 and y equals 31. So this ordered pair, 31 comma 31, is a point in the domain of the original function where both partial first derivatives are equal to 0 at the same time. So this is actually called a critical point. Critical point. So now what you do is use the second derivative test for multivariable functions. Okay, so it says if you have the quantity, little d, and that's equal to, in this case it's h, so it'll be h xx, that's the second derivative with respect to x, so 2 times, right? h y minus, and then the mixed partial squared. So if you have this quantity, there's a couple different cases. So if d is positive and h xx is positive, then we're going to have a min. Okay. If d is positive and h xx is negative, then we're going to have a max. Easy trick, just to memorize it, it's just backwards, right? So if it's positive, you have a min, negative, you have a max. Cheap trick. If d is less than 0, then we have what's called the saddle point. And if d equals 0, we're out of luck, no info. So no info in this case. Okay, so all of this has to occur at a critical point. I just wanted to simplify the notation. So now what we'll do is we'll take the other partials and we'll figure out little d and we'll figure out what this is and see what happens. So let's see it. So I'm going to erase this and we'll keep our critical point on the board. Let's work out hxx. So we're taking the partial of this with respect to x, so we get minus 2. It's pretty easy. Oh, look at that. If you look at hyy, it's also minus 2. And I guess now we need a mixed partial. Well, the mixed partials will be equal here because the second partials are all going to be continuous. So all we need to do is compute hxy. So let's see. So we're looking at this one and we're taking the partial with respect to y, so you get 0. Notice if you go the other way, if you do this for fun, you also get 0. So it doesn't matter which one you use in these problems most of the time. Okay, so now we're going to compute little d. So little d, okay, little d is going to be, let's see, hxx, hyy. It's going to be negative 2 times negative 2 minus, oh, and that guy's 0. And this is equal to 4, regardless of the critical point. Normally you're supposed to plug in the critical point, but there's no x's or y's, right? So you don't have to plug it in. So it's greater than 0 in this case. And so now we just have to check which one of these it's going to be. So here, it's going to be one of these two. So now we just need to check out the sign of hxx. So in this case, hxx is less than 0. So it looks like we're in this case here. And so we have a max. So to actually find the maximum value, we take our points and we plug them back in the original function. So let's go ahead and do that. So erasing this, I'm going to plug everything back into the OG function. So 31, 31. So we get 62 times 31 plus 62 times 31 minus, and then we get 31 squared minus 31 squared. And I think this should be 1922. Okay, so that's your maximum. Most people want the actual point where the maximum occurs. To actually find the point, it's just the ordered triple. It's the point in space. So it occurs at 31, 31, 19, 22. I hope that made sense.